All right, so here is part 2, which is really just the third page. So we're going to divide using synthetic division or long division. So on this, we have to, we don't really have a choice, right? The only way you do synthetic division is if you have a binomial with a 1. So this is 1, but this is not a binomial, so I've got to do long division here. So that means I'm going to have x squared minus 5x minus 5 divided into 2x cubed minus 11x squared minus 5x plus 4. Okay, I don't have anything I had to have a 0 placeholder for. Make sure you catch that if you do. Now, this I do not handle any differently than if this was a binomial that I was dividing in here. I still just look at this first term here and this first term here. So if I take 2x cubed and divide it by x squared, with 2x. So I put 2x over the x. So 2x times x squared, 2x cubed. 2x times a negative 5x is negative 10x squared. 2x times a negative 5, negative 10x. I'm going to go through, make sure I change my signs. 0 out, I get negative x squared plus 5x. Then I bring down my 4. Then I'm going to divide x squared into negative x squared, which just gives me negative 1. This gives me negative x squared plus 5x plus 5. Go through and change my signs. These 0 out, these 0 out, and then I'm just left with a negative 1. I don't have anything else to bring down. I cannot divide that into there. So my answer in the end then is 2x minus 1 plus negative 1 over x squared minus 5x minus 5. It's actually a little easier when it's a trinomial because there's less to divide in, and it's kind of the best you can do. All right. Oops. So now we are going to use the remainder theorem to evaluate. So remember, when you're evaluating, this is called synthetic substitution, which is like synthetic division, that you use the number that they actually give you because that is the solution. And make sure you're drawing the little lines here. Don't have random numbers everywhere. So this is going to be 1, negative 9, 15, 25. So bring down my 1. This is 4, negative 5, negative 20, negative 5, negative 20, positive 5. So what that tells me then is I can't just leave it like that. My answer is that f of 4 is equal to 5. So then do the same thing for this negative 1. Negative 1 divides in here, so I get 6. Now I don't have an x to the 4th term, so that's a 0. Then x to the 3rd is going to be, that's the 3. So 5, 4, 3, 2, 1, and 0. So my exponents, 5, 4, 3, 2, 1, 0. As far as exponents are concerned, so I make sure I have my placeholders there. Bring down my 6, 6, negative 6, 9, negative 9, 10, 10, 8, negative 8, negative 5. So in the end for this one, I get the f of negative 1 equals negative 5. So then I'm going to use the factor theorem to determine if a given binomial is a factor, and if it is, then I have to write it in factor form and all zeros. So I'm going to test that with synthetic division. 1, negative 10, negative 3, 108. 1, 9, negative 1, 12, negative 108, 0. Since my remainder is 0, that means that yes, it is a factor. So I have that f of x is equal to x minus 9 times this right here, gives me x squared minus x minus 12. What I saw some of you doing on this is you were able to get here, you knew it was a factor, but then when you rewrote it, you only used this part and factored this. You can't forget that that's actually a factor. This has to multiply back to give me the original. So I need to factor this here. It's x minus 9. A is 1. That's nice. This is negative, so the signs are opposite. So that would be 3 and 4. 3 being positive, 4 being negative. This is my fully factored form. Then I also have to find my zeros, and that would be negative 3, 4, and 9. There's 2 parts to that answer. All right, so I'm going to test this one. Negative 1, divide that into 2, 14, 16, negative 32. This is 2, negative 2, 12, negative 12, 4, negative 4, negative 36. This is not 0, so x plus 1 is not a factor. All right, so then this next one, try negative 2. Divide that into 3, negative 2, negative 11, 10. Bring this down, I get 3, negative 6, negative 8, 16, 5, negative 10, 0. So it means it is a factor. So f of x is equal to x plus 2. Do not forget x plus 2. And this is going to be 3x squared minus 8x plus 5. So I have to factor this. This is 3, so this is 3x and x. These are this is positive, so the signs are the same, but they both have to be negative. Need them to multiply to give me 5. My only options are 1 and 5. And so if I put the 1 here and the 5 here, it's going to give me a negative 5 and a negative 3, which gives me the negative 8. If you need to factor differently to get the same answer, knock yourself out. That is the fully factored form. And so my zeros then are negative 2, 1, and 5/3. All right, and then last one. 5 divided into 2, negative 7, negative 23, 28, 60. All right, so it is a factor. So f of x is equal to x minus 5 times 2x cubed plus 3x squared minus 8x minus 12. Okay, so then I'm going to need to factor more. I'm going to factor this by grouping, and x minus 5. And then I'm going to do this by grouping, but I'm going to skip a step. So if you need to do the extra step when you do it, it's absolutely fine. But out of these first 2 terms, I can factor out an x squared. Last 2 terms, I can factor out a negative 4. That's going to leave me with 2x plus 3 left over. So then I can factor this farther. So f of x equals x minus 5 times x plus 2 times x minus 2 times 2x plus 3. This is my fully factored form, and if you cannot factor, this test is going to be a disaster for you. I need my zeros. This is going to be plus or minus 2, so I can start with plus or minus 2, and then that's going to be negative 3/2 and 5. And there you go. Make sure you are prepared for me to grade your ISN. Make sure you can factor. Factor, 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 factor.